Okay, third and final video for limits here. One more question, that's it. What we've got is given a piecewise function and then just simply asked to find the limit at two different points. First thing we'll do is just try and answer the first question. So remember, going back to limits of a value x approaching c, so x is approaching 0, the first thing you do is try direct substitution. If it works, then you're done. Whatever your answer is, that's your limit. So in this case, we're finding the limit as x approaches 0. Well, up here we have a function x squared minus 9 over x plus 3 that represents the entire function except the point x equals negative 3. Then we get this 4x. So we're not equaling negative 3. So what we can do is we can look and say, all right, let's plug in 0. And we get 0, here we go, 0 squared minus 9. Okay, we plugged it in. We get negative 9 over 3, which is just negative 3. Okay, we got a number. It worked. We didn't get a DNE. We didn't get a divide by 0. So our answer is the limit of this function, this piecewise function, as x approaches 0 is negative 3. Now, the next question within problem number 4 says to evaluate it at x approaching negative 3. Well, here's where I had a lot of students asking clarifications. It's asking x is approaching negative 3. The students say, well, why can't I, shouldn't I just say 4 times negative 3 and get negative 12, right? Because x is approaching negative 3, well, x is negative 3, the function looks like 4x. And here's why I want to make sure we understand that in a limit, we're not looking at exactly that value per se. Like, yes, I just told you directly substitute it and get a number. But the general sense of a limit is if we didn't have data for negative 3, what would we guess it to be? In order to guess what it is, we need to look at the data around it. This function, y equals 4x, is only data that is good at negative 3. Okay, the tendency or the direction we were heading before negative 3 or after is represented by this upper part of the piecewise function. So we cannot use the 4x equation because the 4x equation isn't telling us what's happening before and after negative 3. It tells us exactly negative 3. So that's where we have to look at it from x squared minus 9 over x plus 3. And here's where we look and say, oh no, we plug in negative 3, we get 0 over 0. Well, that's not going to work. So we need to factor it. The top can look like this instead. Right? And when we say x plus 3 reduces, we say that there is a hole at x is negative 3. But we can continue on and say, now let's try and plug negative 3 in. If we plug negative 3 in, we get negative 3 minus 3, and the limit as x approaches negative 3 of the function is negative 6. So again, I had the most questions probably on just that topic. Now, if you want to look at this graphically, we can, so let me do that. Okay, so what I did, I just pulled that up. I got Desmos. So what we're looking to do is graph the x squared minus 9, x plus 3. I believe maybe I got rid of it. I do have the 4x also I could put in, so y equals 4x. Okay, great. But that's only valid, so your domain is just at negative 3. So let's do this. X equals negative 3. All right, so my apologies, a lot going on here, but the purple line is the function on the top of the piecewise graph. So if we use that, going along, all of a sudden we get to -3, it's undefined. So in the purple tracing, we're undefined. So, but where was it heading? Well, if you look at my y values, my graph was heading to -6 from the right. It was heading -6 from the left. So I would say that the limit is -6. Those who are looking at this graph, the y equals 4x, you were looking at -12, right? That was way down here. But again, this 4x graph is only valid at the point x is -3. Limits don't do that. Limits worry about the left and the right tendencies, not the exact value in that case. So anyways, I think I have beaten that topic enough. So we'll end that. If you have any questions, please let me know. Otherwise, hope you enjoyed.